recording.
It's recording, I think. Post lab number 3. Um, Procedure. I first started by weighing an Alka-Seltzer tablet and recording the weight. Then I filled a plastic bag up with about 15 milliliters of water and I emptied the bag of air as best as I could. I then placed the antacid inside the bag without letting air inside, zipped the bag, and let it dissolve in water. While I was waiting for the reaction to complete, I took a 1-liter beaker and filled it with about 200 milliliters of ionized water. Once the antacid tablet was completely dissolved, I submerged the bag in the beaker and measured the new volume. The displacement was my approximation of the volume in the bag. Submerging the bag completely underwater was a difficult task, and I used the base of a graduated cylinder to push the bag under. This was useful because my hands couldn't completely submerge the bag without influencing the volume. Minimizing errors in my procedure. So I tried to minimize errors by letting out as much air out of the bag as possible. When measuring water volume, I didn't use my hand to push the bag down because my fingers would be submerged in the water, changing the volume. Instead, I found a flat surface to push the bag under the water, the graduated cylinder. However, these techniques weren't perfect. A vacuum or an air pump would be optimal in removing all of the air out of the bag. There was also error in the measurement of the water volume, which I couldn't control. I think using a beaker with more watt markers would help. I calculated the percent composition of sodium bicarbonate to be around 42%. I did this by calculating the number of moles of carbon dioxide from the volume of the bag and using that multiplied by the molar mass of NaCO3H, I found the um, hmm, I found the mass to be 1.37 grams, and dividing that by 3.228 grams, I found that the percent composition of the bicarbonate was 42%. And assuming that bicarbonate and citric acid were present in stoichiometric amounts, the antacid tablet would have a citric acid composition of 96%, which means that I overmeasured the volume of air created by the antacid tablets. I think this could be because I didn't factor out the volume of the water in the bag when I submerged the bag of air underwater. Assuming that a stomach can hold 1 liter of air, consuming a single Alka-Seltzer tablet cannot generate enough liters of carbon dioxide to cause a stomach to burst. I calculated the volume of carbon dioxide created by one antacid tablet to be around 400 milliliters. Um, Also, the stomach has ways to release gas in the form of burps. Given that humans swallow 15 milliliters of air every single time we swallow, it is natural for our stomach to develop ways to get rid of the air. Okay.